A spacecraft no larger than an automobile drifts through the incomprehensible emptiness of space. Positioned 14.5 billion miles away from our home planet. This mechanical explorer, christened Voyager 1 and launched during 1977, carried an original mission timeline of merely 5 years. Nearly 5 decades have elapsed since its departure. Yet this remarkable probe continues functioning against all expectations. However, recent developments have taken a disturbing turn as the craft transmits mysterious signal, structured sequences, rhythmic pulses, and incomprehensible data stream. The question haunting scientists is whether Voyager has discovered something lurking in the stellar void, or whether an unknown presence has discovered Voyager, genesis of the cosmic wanderer. Voyager's origins traced back not to spaceflight ambitions alone, but to an extraordinary celestial phenomenon. During the early 1970s, celestial observers recognized an incredible astronomical event approaching. The 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, would achieve a configuration that manifests only once every 175 years. Such an alignment would permit a single spacecraft to encounter all 4 worlds during one expedition. Utilizing each planet's gravitational influence to accelerate toward the next destination, NASA seized upon this once-in-a-lifetime cosmic opportunity. Engineers commenced developing paired spacecraft capable of enduring Jupiter's intense radiation environment, navigating Saturn's enigmatic ring system, and surviving a multi-decade voyage through the outer solar system's hazardous regions. This ambitious undertaking became known as the Grand Tour mission, subsequently renamed the Voyager program. These mechanical marvels represented the pinnacle of 1970s aerospace technology. Each probe possessed a mass of approximately 1,800 and housed 11 sophisticated scientific instruments. Power generation relied on radioisotope thermoelectric generators, RTG, nuclear power sources that transform heat from plutonium decay into usable electricity. Solar panels would prove ineffective in the diminished sunlight of distant planetary regions, making these nuclear batteries essential. Constructing the Voyagers demanded an enormous engineering effort. Designers faced the challenge of creating systems that would operate flawlessly across many years without any maintenance possibility. Multiple redundant systems were integrated for critical components. While computers received programming to perform self-diagnosis and autonomous repairs when feasible, the onboard computer possessed merely 68 KB of memory capacity, insufficient for storing even a single modern digital photograph. Voyager 2 departed Cape Canaveral on August 20, 1977. Despite its numerical designation suggesting otherwise, Voyager 1 followed 16 days afterward on September 5, launching aboard a Titan II, i.e. Centaur rocket. Due to Voyager 1's superior trajectory velocity, it would eventually surpass its twin spacecraft to reach Jupiter and Saturn ahead of schedule. As both probes journeyed away from Earth, few observers could have anticipated that nearly 50 years later, one would continue generating scientific headlines, not for its discoveries, but for what might have discovered it. Voyager 1's expedition through our solar system achieved spectacular success. Following approximately 18 months of interplanetary travel, the probe achieved its closest Jupiter approach during March 1979. The observations revolutionized scientific understanding of this gas giant. Previous Earth-based telescopic observations had revealed Jupiter as an attractive but relatively simple celestial object, a banded sphere featuring a prominent red marking. Through Voyager's advanced instruments, Jupiter transformed into a world of breathtaking complexity. The Great Red Spot, observed since the 1600s, emerged as a colossal storm system capable of encompassing 3 Earth-sized planets. The colorful atmospheric bands revealed themselves as violent storm systems and high-velocity jet streams reaching hundreds of miles per hour. Jupiter's satellite system provided the mission's most dramatic revelations. Io, the innermost major moon, astonished researchers when Voyager detected active volcanic eruptions occurring in real time, marking the first active volcanism observed beyond Earth. These volcanoes expelled sulfur compounds rather than terrestrial lava, creating Io's distinctive yellow, orange, and red surface coloration. Europa, a smooth white moon covered in crack-like surface features, captured scientific imagination. Voyager's imagery led researchers to hypothesize that liquid water oceans might exist beneath Europa's frozen exterior, a theory subsequently strengthened by later missions and positioning Europa among the solar system's most promising locations for potential alien life. Following Jupiter, Voyager 1 accelerated toward Saturn, achieving its closest approach in November 1980. Once again, what appeared simple from Earth revealed extraordinary complexity. Upon closer examination, Saturn's ring system, resembling solid bands from terrestrial observation, resolved into thousands of individual ringlets displaying braided structures, mysterious spoke patterns, and dynamic movements resembling cosmic choreography. Titan, Saturn's largest moon, particularly intrigued scientists as the solar system's only moon, possessing a substantial atmosphere. Although Voyager couldn't penetrate Titan's orange atmospheric haze, measurements revealed an atmosphere composed primarily of nitrogen identical to Earth's atmospheric composition. This discovery ultimately inspired the Cassini-Huygens mission decades later, which discovered methane lakes and rivers on Titan's surface. After completing Saturn observations, Voyager 1's planetary mission concluded. NASA faced a critical decision. Direct the spacecraft toward Pluto, then classified as our ninth planet, or redirected northward beyond the solar system's plane, beginning its interstellar journey sooner. They selected the latter option, while Voyager 2 continued toward Uranus and Neptune. As Voyager 1 departed Saturn's vicinity, it captured a final planetary portrait series in February 1990 at Carl Schorn's suggestion. These images included the famous pale blue dot photograph. Earth appearing as a minuscule blue pixel within a sunbeam viewed from 3.7 billion miles distant. Schorn's philosophical reflection on this image became one of humanity's most profound statements about our cosmic significance. Subsequently, Voyager 1 ceased visual communication as NASA deactivated its cameras for power conservation. The spacecraft sailed into darkness, blind, but still sensing, monitoring, and transmitting data about interstellar space. Each Voyager spacecraft carries a gold-plated copper disk measuring 12 in diameter, a temporal capsule designed to communicate Earth's story to any intelligence that might encounter it in the distant future. This golden record represents humanity's message cast into the cosmic ocean. The Golden Record's creation story rivals Voyager's own fascinating narrative. NASA provided Carl Schorn's team nearly 6 weeks to determine its contents. 6 weeks to encapsulate all human existence. The team worked continuously, engaging in passionate debates about which music, sounds, and images should represent our world to potential extraterrestrial recipients. The final compilation demonstrates remarkable diversity. The record contains greetings in 55 languages ranging from ancient Akkadian spoken 6,000 years ago to Wu, a Chinese dialect. Earth sounds include thunderstorm, volcanic eruptions, bird song, whale call, human laughter, footsteps, and heartbeats. Musical selections span global cultures: Bach's Brandenburg Concerto, Navajo ceremonial chants, Peruvian wedding songs, and Chuck Berry's Johnny B. Good. The record also preserves 116 images encoded in analog format. Mathematical concept diagrams, Earth landscape photographs, human activity pictures, and DNA structure illustrations. Messages from President Jimmy Carter and UN Secretary-General Kurt Waldheim are included. The record's cover features playback instructions, 16 2/3 revolutions per minute, and a pulsar map indicating Earth's galactic position. These records should survive for billions of years, long outlasting Earth itself. The probability of alien civilizations discovering Voyager spacecraft remains infinitesimally small. Voyager 1's trajectory will pass AC plus 79,388, the nearest star, in approximately 40,000 years, maintaining a distance of 1.7 light-years. However, the record's true purpose transcended practical contact possibilities. As Schorn explained, it represented a symbolic declaration. We achieved this level of development. We hope you exist. These golden records continue traveling outward, carrying children's laughter, whale songs, and Bach's compositions into infinite darkness. They embody humanity's most optimistic and visionary spirit. The same inspiration that created the Voyager program. We couldn't have anticipated that the golden record might not constitute our first message received by another intelligence. Something residing in the interstellar darkness appears to have developed an interest in Voyager itself. Following its Jupiter and Saturn encounters, Voyager 1 entered what engineers designated the cruise phase, an apparently endless journey through the outer solar system with no remaining planetary destinations. Public attention diminished as spectacular imagery ceased arriving. NASA's priorities shifted toward newer missions, including the Hubble Space Telescope and Mars exploration rovers. Voyager maintained its trajectory, traveling approximately 1 million miles daily while steadily approaching our solar system's undefined boundary. Scientists remained uncertain about our solar system's exact termination point. They understood that the Sun generates a protective heliosphere, a region where solar wind, charged particle streams from the Sun, encounters resistance from the interstellar medium. However, this bubble's precise dimensions and external conditions remained unknown. Throughout these quiet decades, Voyager continued transmitting essential outer solar system data. It monitored solar wind variations with distance, mapped magnetic field configurations, and detected cosmic rays, high-energy particles originating beyond our solar system. This information enabled scientists to develop improved models of solar interstellar space interactions. Voyager's onboard existence during these years involved constant battles against inevitable deterioration. Its plutonium-238 powered energy supply weakened by approximately 4 watt annually. Engineers faced difficult decisions about which instruments to maintain and which to permanently deactivate. Camera systems ceased functioning in 1990, followed by other instruments as power availability declined. Simultaneously, the expanding distance between Voyager and Earth created increasingly difficult communication challenges. Voyager's signal became so weak that only NASA's largest deep space network antennas could detect transmissions. By the 2000s, radio signals required over 14 hours for one-way travel at light speed. Despite these challenges, Voyager 1 continued transmitting data from regions never before visited by human-created objects. As it progressed, scientists observed unusual phenomena, solar wind deceleration and magnetic field changes. Voyager 1 was approaching the boundary of known space. By the early 2000s, Voyager 1 detected clear indicators of approaching our solar system's edge. The solar wind-charged particles continuously flowing outward from the Sun experienced dramatic deceleration. External forces were creating resistance. In 2004, Voyager 1 crossed the termination shock, the location where solar wind suddenly decelerates upon encountering interstellar medium pressure. For the subsequent 8 years, it traversed a turbulent region called the Helios Heath, where compressed and chaotic solar wind conditions prevail. On August 25, 2012, everything transformed. Magnetic field strength increased suddenly. Solar particle counts plummeted dramatically while interstellar cosmic ray detection increased substantially. Following careful analysis, NASA announced the historic achievement. Voyager 1 had crossed the helop, the boundary where solar influence yields to the interstellar medium. Humanity had achieved interstellar space, or at minimum the space between stars.